Hi everybody, today we're going to review how to represent positive ternary numbers in binary. Remember, ternary just means decimal. This is the human number system, the system that we understand. And binary, of course, is the number system that computers understand. So let's take this decimal number, otherwise known as ternary, and we're going to convert it into binary. So we don't need a 128, we don't need a 64, we don't need a 32, we don't need a 16, we do need an 8, the remainder is 7, we do need a 4, the remainder is 3, we do need a 2, the remainder is 1, and we do need that 1. So this is 15 represented in 1 byte of binary information. Now, what we want to ask ourselves is, what if the number that we're trying to convert into binary is a negative number? This is where things get a bit tricky. So let me try to explain how this works. The first thing you want to do is look at the negative number and just convert the positive version of that number. So the first step is to convert the positive version. This is sometimes called the absolute value of the number to binary. So we've already done that. We took the 15 and we've converted 15 into binary. So that we've done step 1 already. Step 2, invert all of the bits. So 0 becomes 1, 1, 1, 1, 0, 0, 0, 0. Okay, that's step 2. Invert everything. Step 3, add 1 to the least significant bit. Now, the least significant bit in a byte of data is the bit on the right side. It's this one here. This is the least significant bit. This is it. Of course, the one on the left side is known as the most significant bit, and we'll talk about that in a minute. So we're going to add 1 to the least significant bit. That is the number 15 the number negative 15 represented in binary. Now, do you believe me? Let me explain why this is true. When we want to express a negative number in binary, we need to use a system called twosComplement. This is an example of twosComplement. But let me explain one more thing. In twosComplement, the most significant bit doesn't represent 128. It represents minus 128. Okay, so this is something related to twosComplement. So let's do the maths. Minus 128 plus 64, because we've got one of these, right? We've got 1 minus 128 plus 164 plus 32 plus, whoops, let's try again. I'm going to try again, guys. This is important. Let's do it as an Excel function. Minus 128 plus 64 plus 32 plus 16 plus 1 equals minus 15. Okay, so it worked. So that's how to create a negative number in binary. We use a system called the twosComplement system, and the most significant bit now represents minus 128. Let's also very quickly just explain one more thing. With 8 bits of normal binary, not 2's complement, just normal binary, can you remember the biggest number that we can represent? The biggest number was 255. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. The biggest number was 255. Unfortunately, with 2's complement system, the biggest number that we can represent is 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. Let's just quickly see what that is. So the biggest number that we can represent with 1 byte in the 2's complement system is 127. And remember, this most significant bit here tells us if the number is positive or negative. If this is 1, we're dealing with a negative number. If this is 0, we're dealing with a positive number.